Today, we're diving into what might be one of the biggest upgrades to how AI brains are built. It's a concept from DeepSeek called Engram. And, it tackles a really fundamental problem that's been holding AI back for years. So, to really get why Engram is such a big deal, we first need to look at the problem it's trying to solve. For a long time now, the AI industry has been slamming into this efficiency wall, a deep-seated issue with how these models actually think. For years, the strategy was basically brute force. More parameters, which are kind of like the knobs and dials of the AI brain, more data, and way more computing power. And hey, it worked. But these models got so massive that running them became incredibly expensive. It was like trying to power an entire city just to answer a single question. All that expense led to the mixture of experts, or MoE revolution. That's where a model only activates parts of its brain at a time to save energy. But DeepSeek argues that even these super advanced models are missing a critical component that we humans have naturally: instant, automatic memory. Now, this is where it gets really interesting. When your brain sees the phrase Alexander the Great, you don't have to, compute who that is from scratch. You just know. It's instant. An LLM, on the other hand, wastes a surprising amount of energy rebuilding that identity from clues every single time, even if it's seen that name a million times before. It's like it's constantly relearning things it already knows. So to fix this huge inefficiency, DeepSeek introduced Engram. The idea is simple, but wow, is it powerful. Just give the AI a dedicated memory module. Think of it as a shortcut for all the common repetitive stuff it sees over and over again. And this just nails the core concept. Engram is a memory bank built specifically for common engrams. These are just short word patterns like United States, or by the way, or Princess of Wales. By storing these, the main brain of the model can stop wasting horsepower on the simple stuff and focus its resources on actual, complex things. But how does it work without being super slow? Well, they use this clever trick that's like a giant, perfectly organized warehouse. When the model sees a common pattern, it uses a hash system to instantly find that pattern's unique shelf number out of billions of possibilities. Then it can just pull the pre-computed meaning blob for that phrase. The researchers call this constant time lookup, which is just a fancy way of saying it stays incredibly fast, no matter how big that memory warehouse gets. Okay, but that brings up a really critical question, right? A giant memory bank can have errors, it can have noise. What if it pulls the wrong pattern? Or a memory that just doesn't fit the context of the sentence? The model could easily get derailed. And this is the second really elegant piece of the solution. The AI doesn't just blindly trust its memory. DeepSeek built in a Truth Detector, which is basically a gate that checks if the memory being pulled actually makes sense in the current context. If it's a good fit, that information gets injected. If it clashes, the gate just suppresses it. This makes sure the memory is an assistant, not a hijacker. All right, now for the results. When they tested this new architecture, the benchmarks didn't just show the gains they expected, they revealed something that surprised even the researchers themselves. So, as you'd probably guess, adding a memory module made the model much better at knowledge-heavy tasks. On the MMLU benchmark, which tests broad knowledge, the score jumped from 57.4 to 60.4. This made perfect sense, right? Better memory means better fact recall. No real surprises there. But here's where it gets wild. Engram also boosted performance on tasks that feel like pure thinking, where you'd assume memory wouldn't matter nearly as much. Reasoning scores on the ARC challenge climbed pretty significantly, from 70.1 to 73.8. Even math and coding benchmarks got better across the board. The key takeaway here is adding memory didn't just make the AI a better trivia machine, it actually made it a better thinker. And the improvement in long context tasks was just staggering. On the needle in a haystack test, where the model has to find one tiny piece of information buried in a massive document, accuracy skyrocketed from 84.2% all the way up to 97%. This proved that Engram was doing more than just recalling facts. It was fundamentally changing how the model processes information at a huge scale. So this brings us to the big question. How on earth does a memory module unlock better reasoning? The answer lies in something DeepSeek calls the depth effect. Let's really break this down for a second. Why would a system designed to remember common phrases make an AI better at solving logic puzzles or writing code? I mean, at first it sounds completely backward. This quote from their analysis is the key. It's the real aha moment. They found that because Ingram was handling all the simple, boring work, the main model's processing layers started behaving as if they were much deeper in the network. Layer 5 was already doing the complex work that it used to take the old model until layer 12 to even get to. And this table just sums it up perfectly. A standard model wastes its early layers just reconstructing the same basic things over and over again. The Engram model? It just outsources all that to its memory. This frees up the entire network to focus on higher-level thinking and complex reasoning right from the very beginning. So the model effectively becomes deeper without actually adding any more layers. It's pretty amazing. So what does all of this mean for the future of AI? Well, the verdict is that DeepSeek has given us a new blueprint, one that prioritizes not just size, but intelligent organization. And for anyone worried about real-world performance, this is the kicker. Because the memory lookups are deterministic and predictable, the system can actually prefetch the data it needs before the model even gets to that layer. DeepSeek ran a test where they offloaded a massive 100 billion parameter Engram layer entirely to the much slower CPU, and the speed penalty was a tiny 2.8% at worst. This proves you can bolt on a colossal amount of memory with barely any slowdown. And this leaves us with a final, powerful idea. For years, we've focused on making AI brains bigger. But DeepSeek's research suggests the real path forward is to make them better organized. By creating this clear division between fast memory and deep reasoning, they've made the models smarter, faster, and more efficient, all at once. And the question this leaves for all of us is, what other human-like structures are we missing in our quest to build true artificial intelligence?